Okay, we're going on now to topic 2 of chapter 3, where the plot thickens quite a bit, and we go from simple interest to compound interest. And here, a primer, some basic information about what's going on when we have compound interest is probably time well spent. So let's say we have a principal of $1,000, and this interest is going to be compounded quarterly at a rate of interest of 8%. Now, if this were simple interest, we'd use that formula we had before. There's our principal. And then we're going to combine this, 1.08, multiply it, and we get, after 1 year, $180. But when we compound it quarterly, that means every 3 months, there are 4 quarters in a year, every 3 months we're going to do the calculation. And for 3 months, the interest rate would be 1/4 of the 8%. 1/4 of 8% is 2%. So when we multiply after 3 months, which is a quarter, 1.02 times 1,000, we end up with this. But now, this is the new amount we have in our savings or whatever. We're now going to take this, and that's our new principal. And we're going to multiply it by, again, the same thing. 1/4 of 8%, that's 0.02. And when we do that multiplication, we end up with this amount. Now notice it's a little bit larger than the 140 that we had, $1,040, if it was going to be regular. Because we didn't have 1,000 anymore, we have the interest included in our principal, and that's what we're multiplying. And then this continues, and then we now get $1,061.21, and then we do that the 4th time, and we end up with a final amount after we have compounded quarterly at 8%. The $1,000 is now $1,082.43. Now, if we had simple interest, we would only have $1,080. But because we compounded it quarterly, our interest, in a sense, is a little bit more. We made $2.43 extra. And that's only on $1,000. Now, if somebody invested $50,000, you see, by compounding something quarterly other than annually, you always make a little bit more money because your principal is increasing every time they do the compounding. Now, you know, annually, compounding something annually is once a year. Semi-annual is twice a year. Quarterly is 4 times a year. And then monthly is another common one. That would be 12 times a year. Now, we're going to develop a formula for this, and I'd like you to see where the formula comes from. That notice over here, it was basically this times that. Now, for the second period, since that money was increased, it was actually 1.0 times 1.02, 1.02 times 1,000. Then in this one it was this, and in this one it was that. So if you were to multiply all of this and then times it by that, you would get this final answer. But do you notice something here? We have a factor that we are repeating in a sense. We have in mathematics a way to shorten that. That if this is just used once, we have a 1 there. If it's used twice, we could erase that and put a 2 there. If it's used 3 times, we can erase that and put a 3 there. And if it's used 4 times, we can erase that and put a 4 there. So what do these numbers, in a sense, reflect? Well, they reflect the number of times you are going to compound something. So if it's quarterly, we can just put a 4 there. Okay, that's what it's showing. And by the way, this is all discussed in the textbook. So we're now going to show you what formula is used for that. So we come up then with this formula, that future amount is equal to the principal times in parentheses a 1 plus I, and this I is actually the rate divided by the times something is compounded per year, and then raised to the nth power, which is the total number of compounded periods. And you'll see as we go on just what that means. So I sometimes like to use it in this form, but this is the major form, keeping that I is the rate divided by the number of times it's going to be compounded. So here's our problem. We have $1,000 that's going to be at 8% interest. What will be your future amount after 5 years? Okay, so we don't know the future amount in any of these. And by the way, we're going to look at it annually, semi-annually, quarterly, and monthly. Remember, this is 1 time a year, this is twice a year, 4 times a year, 12 times a year. So we do some substitution. Our principal we know is $1,000. In parentheses, the 1. And then we have 8%. It's only going to be compounded annually. And our period of compounds will be 5. That's what n will be. Now, you add this together, use a caret to the 5th power, and then times it by 1,000, and you get this. So that's not too bad. After 5 years, you've made, at 8%, almost $470. But how about if it's compounded semi-annually? So your period of compounding is twice in a year. So again, the principal stays the same. This 1 stays the same. But now you put your rate of 8% over m, which is the number of times it's going to be compounded in a year, which is a 2. Semi-annually is twice a year. this is going to give you a 0.04 here, plus 1. Now, the period of time that is going to be compounded is 5 years, but it's twice within a year. So it's 2 times the 5 years. So it gives you a total of compounding periods of 10. So again, you get this. This is going to be 1.04. You're going to raise it to the 10th power. Then you multiply it by 1,000. And you end up with this. So notice it's a couple of dollars more than just compounding it annually. Now the same thing applies for quarterly. Our number here is going to be 4. So this is going to become 0.02, that we add a 1 to it. Then now 4 times 5, the number of years, quarterly is 4, 5 years gives you your 20. And then put that in your calculator, multiply it by 1,000, and you get this number. Now notice it's a little bit more each time. And if you compound it monthly, you then get 12 for the month. You divide 0.08 by 12 on your calculator, plus 1, add the 1, then you're going to use the caret. Now remember, this is going to be 12 months times 5 years, which gives you the 60. And then times it by 1,000, and you get that. Again, without a calculator, this would be quite tedious, but that you are allowed to use it. And once again, these are the definitions. And in our textbook, it's page 133, 135. We'll go on to continuous compound interest in our next little lesson. Continuing on with compound interest, on pages 135, 136, we're going to introduce this topic of what we call continuous compound interest. Now, what the book shows on this particular topic, they take you through a series of calculations and some fancy algebra stuff, and they come up with the formula that we're calling Theorem 2 over here. Which is the continuous interest formula. And what they're asking us to do in example 2 is to compare. But before we do this example, let's just spend a little bit of time on what does continuous mean. Well, suppose you took your compound interest daily. How about if you did it hourly? How about if you did it every second and milliseconds? Then as you proceed, there would be a time where the difference would be so insignificant that you've ended up with something. And you don't have to do it anymore. And what they've done is they've developed this special value, which we call lowercase letter e. Now e is a little bit like pi. It is some constant that we use in our calculations. Now on the calculator, like a TI-83 or 84, if you go second value, well, you turn it on first, second value, and then right there, there's where you get your E. and E then is in the calculator. Now it also has a value, 2 point something, and I think it's somewhere in our book here. But I know when I use that value rather than the E from the calculator, they counted my answer wrong because I didn't have enough places. So in your math zone calculators, there is a value for E. And you'll need to ask one of the tutors or instructors to show you where that E is. So that's the one that you're going to use. So what we're setting up then is this is the formula for compound interest, general multi-purpose formula, and then this is the special formula for continuous compound interest. So depending what they ask you, you have to use the correct formula, and these will be given to you on a sheet of paper. If you'd like one even before you take a test, that's fine. We have copies here in Math Zone. So as we look at this example, we have a principal of $5,000. We're going to do compound interest on a daily basis. Our interest rate is 8%. So on a daily basis, by the way, that would be 360 days. The 1 is part of the formula. And then this M, you recall, is the number of times it's going to be compounded in a year. And then we use that up there as well as multiply it by the number of years. And as you see here, the number of years will be 2. So in your textbook, they do give you the problem. Here I'm showing you how to apply it. So there it is set up. So what would your strategy be in doing this? Well, the first thing I would do is I would do this inner division. I would go 0.08 divided by 360. Then I would add 1 to it. That would be in my calculator. I would then go caret, and I would use a parenthesis. So you don't have to multiply this ahead of time. You could just go 360 times 2, end of parenthesis, and I would hit enter. And that would give you a number. You would then take this number, multiply it by 5,000, and this is what you get. Now, I wouldn't do that by hand. I would use a calculator. Now, for continuous interest, again, you have to know how to put it in the system. So there's your 5,000, and I'll do this one with you. Again, I'm not sure you're going to be able to see it. So I put on, clear it, I'm going to put 5,000. 5,000. I'm then going to go second to get my E value. The E value is there. And now I'm going to put in parentheses 0.08, that's my interest rate, times 2, close parenthesis, and then hit enter. And there's my answer, and I've rounded it off to the nearest cent. Now, as you compare your calculations, here, this is 45 cents. The rest of it is the same. This is 55 cents. So by continuous interest, really all you're gaining is 10 cents. But when you put your work in, if you're not careful, and again, don't round off until the very end, because I did some problems when I did the study plan myself for this, and I was off just by a few cents. And so they're asking you to be accurate in your calculations. Okay, we're continuing, and by the way, we are on page 137 here. And we're doing what is called finding present value. So I wrote this out. It says, how much should you invest now to have $8,000 in 5 years if you could have an investment at 10%? And if this were compounded quarterly, or compounded continuously. And again, it's tedious in the sense that what formula do you use? What does all the letters mean? But as you acquaint yourself with that, I think it flows a little bit easier. For instance, we did mention earlier the letter I is actually the interest in a period of time. In this sense, your 10% is your rate, and then it's compounded quarterly. So that's what your interest is. And they use that in a formula. And then they introduce the letter N up over here, which used to be M times T, the number of times you were compounding something times the number of years. So they're using that value. And again, it's quarterly for 5 years. So in this case, N is 20, 4 times 5. So this is the formula they give. And the amount is 8,000. We don't know the principal. The 1 is in the formula, and we know what I is. I is going to be 0.10 divided by 4, which comes out to this. And then our N here is 20. So, what do we do? Well, again, we want to solve for P, the principal. So we want to get rid of this. And again, the easy way to get rid of something in algebra is to divide by it. So this all cancels out. But to keep it as an equation, you must divide the other side by this as well. So here's where your trusty calculator comes in, and your 1 in the math program. You're going to put in the top 8,000 divided by, put that divided sign in there, and then you add these two together. This just is going to become 1 point that, caret to the 20th power. And again, you have to put this, I believe, in parentheses. Once you go 8,000 divided by, put a parenthesis, put this here, put the caret sign, put 20, end of parentheses, hit enter, and this is the answer you get. Now again, part of this is knowing how to set it up. The other part is to know how to use your calculator, and then the techniques. Because just by not putting this in a parenthesis, sometimes it's always better to use a parenthesis to ensure that you are dividing by this complete answer. Or there are other techniques that I'm not going to trouble you with now. You may have other techniques, as long as you get this answer. Now for continuous, again, we're using theorem 2 formula. We know the 8,000. We don't know the P. E is our constant. And we're going to have the rate of 10% times the time of 5 years, which actually gives you 0.50. So I'm going to divide again both sides by E raised to the power of 0.5. You don't need to put the 0 in there. So this part cancels out there, and then I'm left with this on this side. So I now go again, 8,000, and I would put this in a parenthesis, divided by second, or parenthesis, second, get the E value, put the 0.5 in there, close the parenthesis, put another parenthesis in to keep it all nice there, that's what you're dividing the 8,000 by, and this is the answer that pops up. And you round it off to 2 decimal places, which is cents. Notice that if you have continuous interest on your 10%, you have to put in about $30 less to get to your goal of 8,000 in 5 years. But let me just mention, in today's world, to get 10% on something, that's a tough thing to do. Interest rates right now are very, very low. I get 1.5%, and that's hardly anything. That doesn't keep up with inflation even. Okay. All right, in example 4, and we're on page 138, we're dealing with computing growth rate. Now, to give you some background, I think you've all heard about the stock market, where you buy shares of stock, and then as the company does well, the economy keeps doing better, the value of the stocks rise, and then sometime in the future, when you go to sell those stocks, what you originally paid hopefully is worth much more. Now, in our past, you're old enough to know that it doesn't always go up, but it goes down. The famous crash of 1927 and the depression that followed, the current sort of crash of 2007 and 8, the stock market really took a hit. But over time, it tends to go up. And in our textbook here, they do show us this chart, which I reproduced here, taking lots of liberty. It's not exact. But it tells of an investor that had $10,000 to put into the stock market. And in this particular case, he invested in a mutual fund. Now, what is a mutual fund? Well, instead of just owning one company like General Electric or IBM or Apple or any of the other major companies and buying that stock, this mutual fund goes out and buys some of IBM, some of Apple, some of the different types. They'll even do bonds sometime. And there's lots of different kinds of mutual funds. And this one had an initial investment of $10,000, and in 10 years, the stock was worth $126,000. Wow. Well, what they're wondering is, what would be the percent of growth from this point 10 years later to get there. So here we know the initial amount, we know the future amount, the end amount. What we don't know is the rate. And we're wondering if it were done annually and if it was done continuously, what would have been the rates for this? Well, they give us our basic annual rate formula, which is this one right here, and there's our continuous rate formula. So we're going to put in our information. There's our 126,000. There's our 10,000. And we know the rate. We don't know the rate, but we know the time was 10 years. So the first thing we do is we want to get rid of the P, because we're looking for that rate there. So we're going to divide both sides by the P, which is 1,000. So this cancels out, and this cancels out, and I'm left here on this side now with 12.6, and this. Now here's where your algebra skill may come in, but fortunately you could use a calculator. Now, when you have something to the power of 10, and you want to get rid of that exponent, the rule is you take the radical of that expression using whatever number they have here as an exponent as your index number in your radical sign. Now, when this is 10, and this is 10, this radical sign disappears, and all you're left with is what is under the radical sign, which is called your radicand. So that's the special maneuver I did there, and that's critical, and you get this. Now, you can take the 10th root of 12.6, just going to put that in your calculator anyway, but I kept it there for a moment. I want to get R by itself. How do I get R by itself? Well, I have to subtract this 1 from this side, or just transpose it over to the other side as the opposite sign, a negative 1. So I subtract 1 from here, that becomes a 0. Subtract 1 from here, that becomes a negative 1. So now I put in my calculator this, and if you don't know how to do that, you would put 12.6 caret. Now whatever index number you have here, you're going to create a little fraction like so. So 12.6 caret, parenthesis, 1 divided by 10, parenthesis, hit enter, and you get this. Now keep in mind, this is a decimal fraction. We want a percentage rate, so we have to convert this to a percent, move the decimal place over 2 places, and add a percent sign. So here is a person that by investing $10,000 in that mutual fund, and apparently it was very good economic times, they had it increased at an annual rate of like almost 29% interest. Wow, that was great. Okay, my enthusiasm is spilling over. Now let's go to continuously. There's the special formula. Again, we want to find that R that's in the RT up there. And we know the time is 10 years. So again, we're going to do much the same. We want to isolate the ERT. ER10. So I'm going to divide out the 10,000 on both sides. And I get the same, 12.6 equals E R to the 10th. Now here we have to do a little calculation where we're going to take the inverse of this, and by taking the inverse of this, that's what this refers to, the inverse of the E gives us this by itself. And again, check with your tutors and instructors to show you how to do that on the calculator. And then here are the 10s, you're going to cancel out because you want the R by itself. And then you're going to take the inverse of this, divided by 10, and you get this, that you're going to change to a percentage by doing that. So notice if that's done continuously, the percentage is actually lower as opposed to doing it annually. But again, you still end up with this amount, and then we have something to play around with in Math 1127. Okay. Now, there's a sister problem where they use the Russell index. The Russell index, what that does is it takes an average of all the stocks out there. And after 10 years, the Russell index only earned from that initial 10,000, 63,000 in 10 years. That's still pretty good. And the answer to that one is in the book, but it's done in a similar fashion. Okay, in this next example, we're going to compute growth time. Not the rate now, the time. It says, how long would it take for $10,000 to get to be $12,000 if it's invested at 9% and it's compounded quarterly? Now, for this formula, we use, again, one of our standard formulas. We know our future amount is $12,000, our principal is $10,000. Now, the one is there. We have the interest, remember, it is rate divided by the times it's going to be compounded. And this, when we add it to 1, eventually is going to become this. But what we don't know is this time up here, which is months times years. Okay, so we start off in a similar way. We want to isolate this so we can get to work on our n. So the 10,000 divides out on this side. It divides out on this side, and I get 1.2. And again, this becomes this, raised to the nth power. Now here we have to use our calculator in a very tricky way. We're going to actually use the inverse function. And we're going to take the inverse of this side, the inverse of this side, which gives us this. But there's our n right there. So we're going to divide both sides by inverse this. This cancels out. I take inverse of this divided by inverse of this. And lo and behold, I get a number, 24.40. And it's a fraction, so I'm rounding it off. And this brings me to about how many months? About 25 months. So 2 years would be 24 months and another part of a month. Probably like 2 weeks. Okay, you're going to need to be sure you know how to do inverse. This is involving logarithms. And check with the tutors and your math instructors for information on this. Now we're going on to what is called annual percentage yield. Now, whenever you do some banking, and if you have a CD, a certificate of deposit, and you invest that, let's say at, right now the rates are terrible, but it used to be like 5%, and it's going to be compounded monthly. What is the actual percentage yield of that? It's going to be higher than the 5%, and it's usually like 5.15 or something. Well, how do they figure that out? Well, that's what we're going to study here. Now, there is a formula for this. If it's compounded quarterly or monthly or whatever, this is the formula we use. If it's compounded continuously, this is the formula you use. But in our textbook, they're giving us 4 banks, and they all have names. This one starts with an A, a D, a C, and an L. And their listed rates are here. Notice it's just under 5%. This is 0.93, 0.95, 97, 94. And you look at this one, and this one looks like it's the highest, but this is done quarterly, while this one is done daily, this one is monthly, and this one is continuously. Well, I'm not going to do them all. They're all written up in your textbook, but I'll show you how to do one using this here. So the annual percentage yield is this, and it's going to be monthly. There's our yearly percent. So again, when you put this in the calculator, you have to do it very carefully. You're going to put this in there first, divided by 12, then do plus 1. So you do what's in the parentheses first. Then you get that answer, you just put a caret there, which raises it to the 12th power. You get an answer, and then minus 1. And it's a decimal. You have to put it into percent. And when you do that, you get this percent. So that's what I have listed here. I did the same thing for this, use this formula for this one, and now I compare my percentage rates. Because what this problem is asking you to do, and this is on page 140, 141, is which bank rate is the best. Now we said this was the highest, but notice their last part is 6.3. Continuous, a little lower, that's 6.4. Monthly at this one, that's the lowest rate, but your top rate is this bank right here. So they would say that actually in their advertisement, that that's the rate, but this is your APY. You'll see that once you get a little older or have some CDs that you are investing in. For our last example, and this is on page 141, here we want to do some computing of annual nominal rate having the APY of some amount. Now, a bank wants to issue a CD that they want to have the annual percentage yield of 7.5%. But what rate should they put on it as their regular rate? They're going to compound it monthly. So there's our basic formula. And we know our annual percentage yield is 7.5%, so that goes there. We know we're going to do it monthly, so for our M is 12. We don't know the R. And our M up here is still 12. Now again, whenever we have something that's raised to the 12th power, we have to do something special. But the first thing we're going to do is take this -1, transport it to this other side. On this side, it becomes a +1, and we add it to that. And now this step. We're going to take the whatever number's there, put that as the index number in our radical sign. So this is just going to become the radicand. And I already took that one and moved it over to the other side. So I was a little ahead of myself. And I'd have the 12th root of this. So when this just became the radicand, again, this all disappeared. I took that +1 from this side, moved it to the other side. Now I have left R over 12. Well, again, the rule is, if I want to get R by itself, I have to multiply this side by a 12, and I have to multiply this side by a 12. Now remember, it's all of this. So here the 12s cancel out, and I'm left with an R. And I have this. So I moved it over here. Now, what I'm going to do is I'm going to take this under the radical side, and if you don't know how to do the 12th root again, you just put the radicand, caret, and just make that 1 over 12. Put that in parentheses, subtract 1 from that, multiply it by 12, and that gives you approximately 7 and 7.254% as your monthly rate. But the APY, we know, is going to be 7.5. Again, lots of stuff going on here, and it gets rather tedious, but if you need help, check with our tutors, and of course, there's nothing like practice.